Hi everybody, welcome to our last section of beginning algebra. Today we're in section 6.6 and I'm going to show you a general approach to factoring. The problem is with factoring is we've learned all these different methods, and a lot of students, even though they've mastered each method, they're not sure how to look at a problem and decide which method to use. So that's a little bit of a problem. And the solution to that is this general approach. So I'm going to just show you here not any new methods, but just how to decide which method is the best for your particular problem. So this will be a pretty short section. Let's get started. Okay, so like I said, we now have several different factoring methods. Let's look at where we've been. We first learned to factor out a greatest common factor, or a GCF. And then we talked about how to factor by grouping. Then we talked about how to factor a trinomial, what we called reverse FOIL. And then we talked about in the last section how to factor a difference of squares and how to factor a sum of cubes or a difference of cubes. So we've got all these different methods, and how do you know when you look at a problem, if it just says factor, how do you know which one of these to do? That's what we're going to talk about right now. We need a strategy that will help us know which factoring method to apply to any factoring problem. So here is our general factoring strategy, and it's going to be a three-step strategy, and you just need to learn it by heart and practice it over and over so that it will come easily to you when you see a factoring problem. So the first step is factor out any greatest common factor that you have. That is probably not a surprise, because I think in every factoring section we've done so far, we've had problems where we had to factor out the GCF first before we could finish the problem. And so this is true every time you're factoring. Always look for a GCF first. It's easier to pull it out first than it is to do all the hard work with the GCF in the way and then pull the GCF out. So go ahead and do it first. And then you ask yourself, how many terms are there? If there are 4 terms, then you want to see if you can do the factor by grouping method that we learned in section 6.1. If there are 3 terms, you want to see if you can use the reverse FOIL method like we did in sections 6.2 and 6.4. That's what those sections were all about, just reversing the FOIL process. And then if it's 2 terms, you want to check to see if your binomial fits one of these patterns, difference of squares or sum of cubes or difference of cubes, like we saw in section 6.5. So no matter how many terms you have, if it won't do what this is saying here, then you won't be able to do anything else. So if it's 4 terms, you have to use the grouping method. If you can't do it by grouping, you can't do anything to it. If it's 3 terms, then you have to try to reverse FOIL. If you can't reverse FOIL on a 3-term problem, then you can't do anything. If it's 2 terms, then you have to be able to factor it by difference of squares or sum of cubes or difference of cubes. If it won't do one of those 3 things, then you won't be able to do anything to it. So the number of terms really tells you what to do. And if doing this doesn't work, then nothing's going to work. Okay, and then your last step is just check to see if there's anything in your answer that needs to be factored further. For example, does your answer contain a difference of squares? And if it does, you need to factor that down into its factors. Now, if you can't do anything on step 1, so if there's no GCF and then you can't do anything on step 2, that means the polynomial is prime. But the only way the polynomial is prime now is if you can't do a GCF and you can't do any other factoring either. No factoring at all. If you can do no factoring at all, then the polynomial is prime. But if you factor out a GCF, then it's not prime because you are doing some factoring. All right, so let's get some practice problems in here. So here we go. Factor each expression completely. Now, when you read these instructions, I want the word completely to remind you, hey, I need to check for a GCF first. That is supposed to remind you it's not enough to just factor the trinomial or factor the difference of squares. You have to factor out the GCF as well, and you may as well do it first. So when we look at part A, and we see 15x squared minus 5x, That is a binomial, but I see a GCF here. So step 1 is factor out the GCF. I see that 5 goes into both of these coefficients, and I see that both terms contain an x. So our GCF is 5x. And then in parentheses, 5x times 3x makes 15x squared. So I'm going to need 3x here. And then 5x times 1 makes 5x. So I'm going to need minus 1 here. Now verify that if you distributed the 5x that it would go back to this form, and it would. So now we need to ask ourselves, what about this 3x minus 1? Well, that's 2 terms. So remember, if it's a 2-term problem, then it either has to be a difference of squares or a difference of cubes or a sum of cubes for us to do anything else to it. And this is not any of those things. So this cannot be factored further, and this is our final answer. Let's look at part B. Here we have y squared minus 5y minus 6. There is not a GCF here, so there's nothing to do for step 1. For step 2, we say how many terms are there? And 1, 2, 3. This is a trinomial, so I need to try to reverse FOIL. So I'm going to set down 2 empty pairs of parentheses. Y squared is y times y. This last term is negative, so that tells me that the signs in my parentheses need to be different. I'm just going to put a plus and a minus. Now, last times last has to make 6. So the factors of 6 are either 2 times 3 or 1 times 6. I have to choose the pair of factors that will allow me to get the middle term that I need. So outer plus inner has to add up to negative 5y. Okay, so I'm going to just go ahead and put down 2 times 3 and see if that works. Remember, this is a trial and error process. So outer times outer would be negative 3y. Inner times inner would be positive 2y. Minus 3y plus 2y does not add up to negative 5y. If both of these could be the same sign, it would add up to negative 5y, but we can't have them both be the same sign. So that tells me that the 3 and the 2 are wrong. So now I'm going to try 6 and 1. So now let's try outer times outer, that's negative 6y. Inner times inner is positive 1y. Negative 6y plus 1y does add up to negative 5y, so that tells me this factoring is correct. And now we need to, just always look at your answer and see if it contains a difference of squares or anything else that needs to factor again, and of course this does not. Now let's look at part C. Here we have 1,000m to the third plus 1. Now as soon as I see 1,000, that's already making me think about third powers, because I've learned my third powers and I know that 1,000 is the third power of 10. So now I just look at the second term, and that is also a third power. So let's go ahead and write down that 1,000m to the third is the third power of 10m. 10m times 10m times 10m would make 1,000m to the third. And 1 is the third power of 1. So we definitely have here a sum of cubes, third power plus third power, and that tells me we can factor our binomial into a binomial times a trinomial. So remember how we do this. We just learned this in the last section. We say, what is this the third power of? This is the third power of 10m, so 10m goes here. What is this the third power of? This is the third power of 1, so plus 1. And remember the SOAP acronym, S-O-A-P, so same as in the problem, and the next sign we write will be opposite of what's in the problem. So the way to build the trinomial is to say this term times itself. So 10m times 10m would be 100m squared, and then opposite sign, so minus. 10m times 1 is 10m, and then AP for always positive, and 1 times 1 is 1. So there is our factoring for the sum of cubes. Here are just a few more practice problems for us. Remember, there's no new information in this section, really. We're just pulling it all together with this general strategy. So we already know how to factor all of these. We just have to learn how to look at a problem and decide which method we're going to use. So here in part D of this practice problem, we have 4 minus 2q minus 6p plus 3pq. Well, I don't see anything that goes into all four terms, so we don't have a GCF. But we do have four terms here, so the fact that it's four terms tells me I have to use the grouping method. So in the grouping method, you remember, we factor the GCF from the first two terms. What goes into both 4 and 2? Well, that's going to be 2. So 2 times 2 makes 4, and then 2 times negative q will make minus 2q. And then for the second group, notice starts with a minus, so I'm going to have a minus here. And then let's look at 6p and 3pq and decide what our GCF is. 3 goes into both terms, and they also both have a p, so our GCF is going to be 3p. And then we'll have our empty parentheses. Negative 3p times 2 would make negative 6p. Negative 3p times negative q would make positive 3pq. Remember, when the second group starts with a minus, that forces us to have to change this sign. Now notice that both groups contain a 2 minus q. So we're going to factor out 2 minus q, and that's going to leave us with 2 minus 3p. And so there is our factoring for this expression. Now let's look at part E. You can see that it has 3 terms, but before you start trying to factor the trinomial, always check for a GCF. So here I see 28 and 6 and 10, and all of these are even numbers, which means 2 goes into each one. So we're going to factor out a 2. We cannot factor out an x because this last term does not have an x, so our GCF will just be 2. And now 2 times 14x squared makes that first term, 2 times 3x makes that second term, and 2 times 5 makes that third term. So now we have 2 times 14x squared plus 3x minus 5. And we should try to factor this trinomial. So I'm going to keep my 2, but I'm going to set down 2 empty pairs of parentheses. 14x squared is most likely 7x times 2x. I'm just going to go ahead and write those in. Now, there's another pair of numbers that can multiply together to make 14x squared. It could be 1x times 14x, but I just don't think so. I'm going to bet on this first, and then if this doesn't work, I can try the other combination. This minus sign tells me that these signs need to be different. I don't know whether the plus should go here or here. I'm just going to put it here, and we'll see how things work out. This number is 5. The only pair of numbers that makes 5 is 1 times 5. So I'm just going to put the 5 here and the 1 here, and let's see if we can get 3x in the middle. Outer times outer is 7x. Inner times inner is negative 10x because of that minus sign. Now 7x minus 10x is negative 3x, but I need it to be positive 3x. So I'm going to need to switch these signs right here. Okay, now let's make sure that our middle term is right. Negative 7x plus 10x is positive 3x. So this factoring works for that trinomial, and then if we distribute the 2, we can go back to this form. So this is our final factoring here. On part F, again we have a trinomial, but we definitely have a GCF to deal with first because we see that each term contains an m. I also see that each coefficient can be divided by 3. So let's say that our GCF is 3m. Now, for the trinomial, we can say 3m times 6m squared would make that term, 3m times 1m would make that term, and 3m times negative 2 would make that term. You can just mentally distribute that 3m and make sure that it goes back to this form, and it does. But now we have a trinomial here, and we need to try to break this down into 2 binomials. So we will keep the 3m, and we'll have 2 empty pairs of parentheses. Now 6m squared is most likely 3m times 2m. That's not a guarantee because 6m squared could be 1m times 6m, but let's try this first, and if it doesn't work, then we know what to try next. Okay, this sign tells me that these signs in the final factoring need to be different. So I'm going to go ahead and put down a minus and a plus, and 2 could only be 1 times 2. So I'm going to put my 2 here and my 1 here. And the reason I did that was because I know the 2 can't go here because if I put the 2 here, and I already have a 2 in this parentheses, that creates a GCF, but there's not a GCF here. So there should not be a GCF in my next step. Okay, so I knew I had to put the 2 here. And let's see if we get the middle term we want. Outer times outer is 3m. Inner times inner is negative 4m. Negative 4m plus 3m adds up to negative 1m, but we need positive 1m. So that tells me we need to change these signs. And that's it. And so this is the final factored form for this expression. Here are a few more. Again, these are just practice problems, so let's factor each expression completely. Here we have k squared minus 6k plus 16. There is no GCF in this expression. Nothing goes into all 3 terms, so we can go straight to step 2. This is 3 terms, therefore we reverse FOIL. So there's not going to be a GCF, and k squared is going to be k times k. The signs in my parentheses need to be the same because this is positive, but they both need to be negative. So I'm going to put minus minus. And then 16 could either be 1 times 16 or 4 times 4 or 8 times 2. Those are our only 3 choices. So the first thing I'm going to do is try 8 times 2. And let's check our middle term. You might be thinking that like negative 8k plus 2k would be negative 6k, but here we don't have the plus 2k. We're going to get minus 2k and minus 8k, and that's going to add up to minus 10k, not the minus 6k that we want. So these two numbers cannot be right. Remember, we can't change this sign because if we change this sign, we won't get positive 16 on the end. Okay, so we can't use the 8 and the 2. Let's try 4 and 4. Here we're going to get minus 4k minus 4k, and that's going to make minus 8k, not minus 6k. So that didn't work. And our only other choice would be 1 times 16, and you can see, obviously, that's not going to work either. So what we just found out is that this trinomial is prime. Let's look at part H. Here we have 12y squared minus 75. We don't see 75 that often because it's kind of a larger number for us. And when you look at it, you first notice that 5 goes into it, but don't forget 3 will also go into this number because you know that 3/4 makes 75 cents. So 3 times 25 makes 75. So let's definitely factor out a GCF of 3 here. Okay, 3 times 4y squared would make that first term, minus 3 times 25 makes that second term. Now this, in parentheses, this is 2 terms. So it's got to either be a difference of squares, a difference of cubes, or a sum of cubes if we're going to do the next step. Well, here you know that 4 is a square and you know that 25 is a square. So clearly 4y squared is the second power of 2y. Clearly 25 is the second power of 5. So we do have square minus square, and that means we can go ahead. So keep the 3, but set down your 2 empty pairs of parentheses. 4y squared breaks down into 2y times 2y, and then minus 25 becomes minus 5 and plus 5. And there is our factoring. And then for this last part, first look for a GCF. I see 16 and 8, but then I don't get anything on this last term that gives me a GCF. They do not all contain an A. They do not all contain a B. So there's no GCF here besides 1. And that means we can go ahead with our factoring. So this has 3 terms. We're going to try to reverse FOIL. You know, 16a squared could be 1a times 16a, or 4a times 4a, or 2a times 8a. We don't know yet which one is correct, but we just have to pick a pair of numbers to work with and then just try each combination until we find one that works. So let's start with 2a times 8a, and then we can tell from this sign that these two signs need to be the same, and this tells us they must both be positive. So let's put plus signs in both places. B squared has got to be b times b. Alright, now check to see if you're going to get your middle term. Outer times outer would be 2ab. Inner times inner would be 8ab. So obviously 2ab plus 8ab is not going to add up to 8ab. So this factoring does not work for us. Let's try erasing the 2a and the 8a because really nothing else can be changed. The plus signs can't be changed because these signs are set, and the b squared can't be changed because b times b is the only way to get b squared. So if we're going to be able to fix this, it's going to have to be by changing the 2a times the 8a. Let's try 4a times 4a. So now outer times outer is 4ab. Inner times inner is also 4ab. So together, 4ab plus 4ab adds up to 8ab. And that's what we wanted, so this factoring is complete. Now let's look at part J. Here we have 4x squared plus 36. So remember, we need to make it a habit to always look for a GCF first. So I noticed that 4 goes into both of these numbers. Let's factor out the GCF 4. Remember, if we have a GCF, that means our problem is not prime. Don't write prime here because we are about to get a GCF out of this. So if we factor out a 4, then we're going to have 4 times x squared to get this term and 4 times 9 to get this term. Okay, now we want to look at this binomial in parentheses and see if it is a difference of squares or a difference of cubes or a sum of cubes. If it's not any of those things, we have to just leave it alone. And in fact, notice that this is a plus sign, so this cannot be a difference of squares, and it can't be any of the cube things because these are not cubes. And so this is as far as we can go with this problem, but we definitely did not write that it's prime because it's not prime because we did factor a GCF out of it, but that's as far as we go. Now look at this trinomial on part K. I think you probably can see here that we have a GCF. 6 goes into each of these coefficients, and we have a common p factor of p to the third. So let's factor out a GCF of 6p to the third. Now we need to look at the trinomial that we get inside the parentheses. So 6p to the third times 2p to the third would make this first term. 6p to the third times 3p squared would make that second term. And 6p to the third times negative 4 would make that fourth term. Okay, so now we have 3 terms inside our parentheses, and the only way to factor something with 3 terms is to reverse FOIL. But in this case, we're not going to be able to reverse FOIL because this is not a square and a first power and a constant. This is a cube and a second power, and we can't do anything with that. So this is as far as we go. Now, I just want to remind you one more time on problems like this. The trinomial turned out to be prime, but the problem itself was not prime because we did get a GCF from it. So do not write prime under problems like this where you've been able to do some factoring. Now let's look at our final example for this section. Here we have 81x to the fourth minus 16. Notice that there is not a GCF besides 1, so that lets us go on to step 2 of our strategy, which is determine how many terms you have. So we have 2 terms here, so that means we're either dealing with a difference of squares or a difference of cubes or a sum of cubes. Clearly, because you can see the fourth power, the cubes are out. This has got to be a difference of squares if it's anything. So sure enough, we do have the difference here, and 81 is a square and 16 is a square, and x to the fourth is x squared times x squared. So we do have a difference of squares here. Let's go ahead and set down our 2 pairs of parentheses. 81x to the fourth has got to be 9x squared times 9x squared, and then minus 16 has got to be minus 4 times positive 4. And that is the way to factor that difference of squares. But now look at your answer. And notice that the answer itself contains another difference of squares. This first parentheses that contains the minus, this is a difference of squares. So this is going to need to be factored, and the 9x squared plus 4 cannot be factored further because it is a sum of squares. So now let's set down 2 empty pairs of parentheses for that first factor, and we're going to go ahead and copy down our 9x squared plus 4 so we don't forget it. 9x squared can be 3x times 3x, and then the minus 4 can be minus 2 and plus 2. And if you were to multiply these two together, they would go back to 9x squared minus 4. If you multiply these two factors together, it goes back to this. So we know this factoring is right, and we know it's complete because this is a sum of squares and cannot be factored. These are linear and cannot be factored any further. So that's it. The more practice you get with factoring, the better you will get at it. You have to think about it. You have to practice it. You have to see lots of different problems, kind of like a batter in a baseball game who's gotten to bat against lots of different pitchers, becomes a better batter. You'll become better at factoring if you work lots of different factoring problems. So that's why I did plenty of examples in this section with you. When you do the homework, make sure and take your time and practice, and good luck.